morning to everybody. Today I want to explain about module 5. That's title of the module 5 is pile foundations of code number 18CV62. Subject name is applied geotechnical engineering. This comes under 6 semesters in civil engineering departments. Today I want to explain in module 5 lecture 1 contents, introduction, types and classification of piles, single loaded pile capacity in cohesionless and cohesive soils by static formula. Now I want to explain about introductions of pile foundations. Pile foundations are one form of a deep foundation. Piles are relatively long, slender members that are driven into the ground or cast in situ. Piles have been used from prehistoric times. Today, pile foundations are more commonly than any other type of deep foundation, capably where the soil conditions are unfavorable for the use of shallow foundations. Now I want to explain about types of piles and classification of piles. Types of piles: long piles, short piles, laterally loaded piles, axially loaded piles, inclined or batter piles, fender piles. Okay, so next one more type of pile is under rimmed piles. Now I want to explain about classification of piles based on the function: end bearing piles, friction piles, tension or uplift piles, compaction piles, anchor piles, fender piles, seat piles, batter piles, laterally loaded piles. Based on composition and material, piles are classified as timber piles is nothing but a wooden piles, steel piles, concrete material piles, composite material piles, and also piles are classified based on installations, that is driven piles, cast in situ piles, driven and cast in situ piles. So these are the classification of piles based on the piles. Next I want to explain about single loaded pile capacity in cohesionless and cohesive soils by static formula. Now I want to explain about pile capacity. What do you mean by pile capacity? Okay. Capacity means it carries the maximum load while occurring by the building as well as line loads, wind loads, etc. on the pile caps through the load is carried along the length of the piles. Here, the ultimate bearing capacity of a pile is the maximum load it can carry without any shear failure or excessive settlement. The bearing capacity of a pile depends primarily on the type of soil through which it passes and on which it rests and on the method of installations. It also depends upon the cross section and length of the piles. Okay. Next, there are so many methods are available to determine ultimate load capacity of the different types of piles. Here I want to mention the so many methods to calculate ultimate load capacity of the given pile with respect to the materials as well as load carried by the buildings. Okay, here there are four methods are there. One method is static analysis, second method is dynamic analysis, third one is load tests on pile, and the fourth is penetration tests. The first two tests are analyticals and the other two tests are field or practical oriented methods. Okay, now I want to explain about in details to calculate the ultimate capacity of the pile by static analysis. Here the ultimate bearing capacity or bearing load of a pile, that is Q up, is considered to be the sum of the end bearing and skin friction resistance. Based on these definitions, the equation is given by Q UP equal to QEB plus QSF. This is the equation 1, where QEB is the end bearing resistance and QSF is the skin friction resistance. QEB and QSF may be analyzed separately since both are based on the state of stress around the pile and the shear patterns that develop at failures. According to basic, only punching shear failure occurs in the foundations irrespective of the density index of the soils. So long as the depth to width ratio is greater than 4, then the equation is given QEB equal to QB into AB, and QSF is based on the skin frictions. QSF equal to Fs into As, where QEB is the end bearing resistance and QSF is the skin friction resistance, and QEB and QSF may be analyzed separately since both are based on the state of stress around the pile and the shear patterns that develop at failure. The general form of the equation for QB presented by various investigators is given by the following equations. That equation is QB equal to CNC plus 0.5 times gamma B n gamma plus Q into n gamma. Okay, in these equations, QB is the ultimate bearing capacity of the pile and C is the cohesive soil in kilonewton per meter square, and NC is the bearing capacity, that is Turkey's bearing capacity factors, and gamma is the unit weight of the soils or density of the soil in kilonewton per meter cube, and B is the diameter of the pile or width of the pile in meter. N gamma is the Turkey's bearing capacity factors. Q is overburden pressure and is also calculated by the relation depth of the soil into unit weight of the soils, and it's expressed in kilonewton per meter square, and NQ is the Turkey's bearing capacity factors. Okay, next, how to calculate ultimate bearing capacity in cohesionless soils, that is in sand. Here for square or rectangular piles, QB equal to 0.5 times gamma B n gamma plus Q into n gamma. If circular piles with the diameter D, the equation is given by QB equal to 0.3 times gamma D n gamma plus Q times NQ, where gamma is humidity of the soil, B is the diameter of the piles or width of the piles. Q is the overburden pressure and is calculated in terms of density of the soil into depth of the soil. And NC, NQ, N gamma or the TAS is bearing capacity factor obtained from the tables given with respect to angle of internal friction value. And D is the diameter of the pile in meters. With driven piles, the term involving the size of the pile is invariably negligible when compared with the surcharge term. Thus, for all practical purposes, QB equal to Q into NQ. The surcharge pressure Q is given by Q equal to gamma into Z, for Z is less than ZC. If Q is gamma into ZC, if Z is greater than ZC, where Z is the embedded length of the pile and ZC is the critical depth in meters. Okay. Now I want to explain about to calculate ultimate capacity of the piles in clay soils. For piles in clays, QB is given by QB equal to CNC plus Q. Since NQ is 1 and N gamma is 0, for phi equal to 0 degree, the value of NC ranges between 6 and 10. However, a value of 9 is taken conventionally. It is also considered that Q is not significant compared to CNC. Hence, for all practical purposes, QB equal to 9C. The general form for the unit skin friction resistance Fs is given by skin friction resistance Fs is equal to C plus sigma tan dels. Okay, C plus sigma tan del, where Ca is the unit adhesions, sigma h is the average lateral pressure of soil against the pile in kilonewton per meter square, and del is the angle of wall friction, which depends upon the material of the pile and the condition of its surface. Okay, so now this slide is given for the multiple choice questions which are discussed earlier in all the slides. Here there are different questions are asked, and these are the references are given in this lecture 1, and thank you one and all. Over. Okay.
તો વાતી કરારો તેરે દિન છે ના માર બેટા કે વાતી કરારો તો म्हणून तो 2 फुटच पचवलं.